Okay, so this is a little bit of homeschooling. We're still in lockdown through the coronavirus and we've got another 3 weeks. So we're doing a little bit of electronics. This is Thomas, he's my son, who's 10 years old. Can you tell us what you're going to make, Thomas?
I'm making an electronic dice.
Okay, can you show us what it looks like? Okay, so we're going to solder the components onto this prototyping board. Just zoom in there. Hold it still, please. There you go, and then turn it the other way. And this board, how are we going to drive this board, Thomas? What's it going to be connected to?
Through a Raspberry Pi.
Through a Raspberry Pi. So we're actually going to have to program this board. Right, so the first thing we're going to do is we're going to position the resistors. I've already cut a little bit of this prototyping board out, so we're going to have a look at types of resistors, how the values change and why there are different values. We're not going to go into much detail, but we're just going to highlight the obvious ones, which are resistors of different values, and then with the LEDs that they have to go a correct way around. So this is the first stage, we're soldering in the resistors. I have taught my son to solder already, so hopefully we should be okay. We've mounted and we're soldering all the resistors in one go. Okay, we've soldered all the resistors in. How did that go, Thomas?
Badly.
Why did it go badly?
Some of them are sticking up and some of them have stayed down.
We thought we'd be clever and put everything in the vise to make it easy to solder, and as you can see, some of them have dropped down. So if you're doing this, probably best to bend the legs over on the other side to hold them in place. This now allows us a perfect opportunity to show us how to use the desoldering tool. So the resistors are now all in, and I think it's a useful time to cut these tracks in between the resistors here. So I'm just going to get Thomas to use this 3.5mm drill bit and just demonstrate what he needs to do is put it in between the resistor and twist it. Put it in between the resistor and then twist it just to break the track. I think this is not particularly easy for Thomas to do, but I'm going to let him struggle. You can get a special tool for this which has a handle, which actually might be slightly more easier for Thomas, but no, I think you're doing it, aren't you? Are you on the third one?
Yeah.
You've got to make sure the track is fully broken. Just to show you this board, there are actually quite a few breaks in the tracks. There's 7 where the resistors are down the side here. There's another couple here where the 3 LEDs go along. So Thomas has finished doing these tracks, but there's a couple of little mistakes. The first one is this one shouldn't have had a cut in it. Doesn't matter because that shows us another lesson, and this one down here isn't quite cut through. So we just need to do that one a little bit more. So we're now going to mount the LEDs, and this is a good opportunity to point out how you recognise which way around an LED should go, because a LED can only go one way for it to work. So you've got one short leg that represents the ground, or if you look at the body you might, oops, come out of focus there, that little flat there on the body, let's bring it back in the camera, also represents the ground. There, you can see it now. So you've got 2 indications. That flat is also the short leg which goes to ground. So we're now soldering the LEDs into place, and the recommendation here is to just solder one leg on each LED. Once you've done all 7, then take the board out of the vise and one by one push the LED down with your finger while melting the solder on the one leg. That will then pop it back into position, because at the moment they might have fallen down. So we've soldered one leg of the LEDs, and now what I tend to do is put my finger on the LED and then melt the solder again just to push it down. Okay, and then once they're all in the right position we'll solder the other leg. So So that's all the LEDs in place. So we've now put this switch into place, and that needs soldering on the backside. And then after that there's 6 links to do, and then the wires to connect to the side. Obviously it's important with the switch that it is mounted the correct way, otherwise you'll just be switching against a track. So I've already tested this switch and it is correctly mounted. So I've put all the links into the board. We've got one extra link because that resistor there ended up being a little bit short, so we've got a little link there just to put the ground to it. And now we're going to put it in the vise and just solder those up. So this is the last link. This is because we accidentally cut one of the tracks we didn't need to. So there you go, that's bridged that track. So the board's now finished, and we're just tinning the ends of the strips so we can solder the wires in place. So we're now soldering the wires into place. I've already made the wires up. They've basically got a small connector which fits onto the terminals of the Raspberry Pi. I think they're called dew point. So each one's got one of those crimped onto the end, and then I've heat shrunk over the connector just to avoid any shorting. I've asked Thomas to install the red one and the black one first because they're the critical ones. All the others can go wherever he likes, because it will be up to him to connect them to the right position on the Raspberry Pi. So that's all 10 wires in place. I'm just going to check over the board, and then we will check it on a 3.3 volt power supply because I don't want to connect it to a Raspberry Pi until I've checked there's no shorts. So I've connected the ground to this little power supply unit. It's the type that you'd fit to the end of a strip board, as you can see, and it just supplies the strip board with 3.3 volts or 5 volts, or a combination of both if you wish. And all we're doing is trying each LED one after another just to confirm it works. There you go. So all of them came on.
Apart from the yellow one, I think.
So the yellow one's a switch, so we need to check that separately. So this time, to test the switch, we've taken the switched wire, connect it to one of the LEDs. Then we've got the ground going to the ground on the power supply and the positive going to the power supply. So what should happen is when we press the button here, the LED comes on. So that now tells us the whole circuit's working. So I can quite happily put this on the Raspberry Pi without any fear that we're going to damage something.
So I've connected the board to the Raspberry Pi, and we've loaded a program so we can test the dice works. All I have to do is press the button and it displays a number as a dice number.
I press the button again.
On the screen you can see the numbers you've got.
Right, go on and press the button. So there you go. But that is how we make electronic dice using the general purpose I/O of a Raspberry Pi.
Thank you for watching. Hope you've enjoyed my video.